the way the way to do that first for looking at X-ray machine circuitry is to first start and say, what are the sections to an X-ray machine's circuitry? Okay. Once you understand the sections, then you can put them together to become the full circuit, and you'll understand it a little better. So we have three parts: the control console, where we make all of our settings at; the high voltage section, which has to run on direct current; and the X-ray tube's filament. Think of the filament like a coil of wire in a light bulb, which is really exactly what it is. What you won't see in this is the main circuit breaker for the building. Okay, so that's just assumed that the circuit breaker for the building is on and we got power running to our equipment. Okay, but you should know that every X-ray machine has a circuit breaker. It's usually listed as the emergency shutoff switch with a little label above it that says, if in case of emergency, this switch has to be shut off. But we won't be showing that in this circuitry. Okay, so let's take a look here at the circuit. If you would like, let's just check, make sure we know what page this is on. If you'd like to have this out in your book, it might be a little more helpful than looking up on screen, or maybe doing both at the same time. But let me make sure we've got the right page for this. If you find it first, let me know. It's a race. Okay, here we are. I got it on 134 of the text is where the full image is at. That's second page of chapter 8. So good. If you'd like to have that out in front of you, you're welcome to. Actually, move that. Okay. So up in the top left here, up in the top left is the entire circuit, and we see each part of the circuit separated here into console, X-ray tube filament, and high voltage section. Okay. So let's run through console circuit first, okay? So console circuit has two things. What were the two controls at the console that we just finished the last notes with?
Voltage and amperage.
We use big voltage and small amperage, right? So we have KV and MA, high voltage, low amperage, okay? So here's the power tapped off, where we tap off power, where we get our power from, okay? We see a switch to shut the machine on and off, okay? Up here, B is what's called an auto transformer, okay? Current will run through this coil of wire like that, okay? It doesn't, for our purposes, matter which direction the current's running, but let's say it's running like that, okay? What you'll do with an auto transformer is you will plug in to the coil somewhere along here, okay? The place that you plug in at is your voltage, okay? So plug in higher or lower changes the voltage setting. So when you go over to your console and you click the voltage knob, one direction or the other, you're changing where this power line plugs in at somewhere along that coil, okay? What it's actually doing is changing the resistance felt in this wire, and we know resistance can change voltage. Okay, so it's called an auto transformer. It uses no magnets, just a coil of wire, and you literally plug in, they call it tapping in, you tap into that coil of wire somewhere along here, raising or lowering where you're tapping in from. Okay, and by that you can change the voltage. So you already are changing voltage here before you get to over here with this step up transformer. So we're setting our voltage while it's still low. Then we can send it through the step up transformer. The step up transformer just has an amount that it steps up to. Okay? We can only change the voltage here. So when you play with your settings, and this is what you should remember, when you change kilovoltage, you are adjusting the auto transformer. Okay? Alright. C is your exposure switch, okay? This switches up or down. Now D here, D is the last part of the voltage side of the control console. D spans from one side of a wire to the other side. You'll notice where D is up here, this wire runs into the auto transformer and then out of the auto transformer, okay? And D is a meter that spans between the incoming and outgoing wire, the current going in and current going out. Anytime there is a meter that spans, let's say, from the positive to negative side, okay, of a circuit, touches both sides of the circuit, this can measure the difference in voltage going into and out of the circuit. This is our voltmeter, okay? The auto transformer sets the voltage, but the voltmeter reads the voltage out to you so that you can see what your setting is, okay? So over on our control console, when I change my voltage settings here, I see it reflected on my meter. The meter is set up to measure voltage going into and out of the step-up transformer. I want to see what my setting is. Otherwise, how do I know what I'm setting things to? This is the voltage side of the circuit for the console. Down here is the milliamperage side of it. There's another switch here, and then you have this little series of 5 different spots with one arrow pointing towards one of the 5. This is your milliamperage setting, okay? The milliamperage is set by sending power through a series of these, through one of a series of resistors, okay? So each one of these little devices here would have a different amount of resistance, okay? We know from Ohm's law, if you fix the voltage moving through a circuit, so voltage would stay fixed, okay, moving through this, amperage would be changed, resistance would be changed by plugging into one of these 5. You can only plug into one at a time. If you want to change your milliamperage setting from 50 to 100, you go from plugging into one of these to the next one, okay? The 50 milliamp circuit would have an amount of resistance, okay? Then you plug into the 100 milliamp circuit, right? It would have less resistance, so higher amperage, okay? Each one of these is an individual resistor, and you can only plug into one at a time. When you change your milliamperage setting, you're changing which one of these resistors you're plugging into, changing the amount of resistance. We know from Ohm's law, if resistance changes, amperage has to change. So when we want to change amperage, we change which one of these resistors we're plugging into. If you have, let's look over at this console. How many settings do we have? We've got 1, 2, 3, 4 different milliamperage settings. So we're going to have 4 different resistors that we could potentially plug into when we change our milliamperage number. By changing each milliamperage number, I'm changing which resistor I'm plugging into for the amperage. You'll see that this here leads to this, which then leads to the X-ray tube's filament here. Follow these wires, it leads to the X-ray tube filament wire. This is your resistor changing your milliamperage. So control console changes voltage and amperage and allows you to make exposures as well as turn the equipment on and off. Where's best to go to next? We should probably go to the filament side of things, okay?
Question.
Yes, please.
So from the original, is it the transformer?
Sure.
No. The original source of power.
Power. So yeah, access to power. Good.
So there's a split off. So one's going to the KV, and the other lines are coming to the
down here.
Yeah.
To the X-ray tube filament.
Right. So
yes.
that's the MA side.
So notice that these two directions, the rough direction going this way,
right.
and the rough direction going this way, right?
Right.
This one up here is sending power through a number of devices to send electricity across the X-ray tube. Okay? This one down here is leading to the X-ray tube's filament to be the source of electrons to send across the X-ray tube.
Okay, I was like, wait a minute, the
yeah.
lines going into...
Yes. So we have the top part of this circuit is what's creating the push or pressure to push the electrons across the X-ray tube. The bottom side of the circuit is what's giving us the electrons to push.
Okay.
Yeah, good. Okay, so we've got control console side of things. let's move to X-ray tube filament. And in a little while here, let me see if I've got a decent picture of this here. No, but in the upcoming slides we will. So, do some good imagination for now. Maybe, hopefully you've read the material and you've already seen what the X-ray tube actually looks like. We're looking at cartoon pictures right now. So anyways, what is important is that from here, whatever setting you make, the power goes to this next thing labeled K. Okay? K, if you look, it looks like the windings are really compact on the primary side and really spread out on the secondary side. They're trying to show you that in this transformer, okay, current runs through this wire and induces current in this wire. Okay? This wire on the secondary side has less windings, okay, less windings than the primary side. Less windings on the secondary side means lower voltage on the secondary side, okay? Higher amperage, lower voltage. With lower voltage and higher amperage, now we can send low volt, high amperage current through this filament, okay?
So how do you have higher amperage and, well, lower voltages because it has less windings, right?
Mm-hmm.
But how do you have more amperes?
Because the resistance goes down.
Oh, okay.
With the resistance, Ohm's law, with the resistance going down, amperage goes up and the voltage changes too.
Okay.
So both things are happening here. So you're ending out of this step down transformer. So here's something important to remember out of all this. The filament circuit uses a step down transformer to lower voltage and raise amperage from whatever it was when we plugged into the wall. Okay? We want low voltage running through this filament. Good. So, yeah, go ahead. One more time.
A step down what?
Step down transformer. So step down transformers are found on the filament side of the X-ray tube circuit, and their function is to lower voltage and raise amperage. We want low voltage, high amperage moving through the filament. Okay. This filament is, so for those of you who have actually put your hands on an X-ray machine and made an exposure, when you hold the prep button to spin the rotor and you hear the X-ray machine start to make noise, one thing you're not hearing or seeing is that when you press the prep button, before you press the exposure, while the anode spins, the filament side of the circuit is charging. Okay, it's building a charge of electrons on that side. Those cloud of electrons that we'll name later is let go to cross the X-ray tube when you hit the exposure button. Okay, so but when you hit the prep button, you're spinning the disc. You can hear that happening, and you're building charge in the filament circuit.
So on the diagram,
Mm-hmm.
the prep button is the single wire that's coming from the top circuit into the filament. No.
Here?
At the top. No, the one wire coming across.
Oh, here.
Yeah.
This is our exposure. This is going to be connected when we make our exposure.
That would be triggered by the prep button. The arcing of the electron.
This switch
Yeah.
is the switch to make the exposure.
Right.
And so this switch is when this switch is closed, when you press this lets the cloud of electrons pass across the X-ray tube.
Okay, that's where I was going.
When you close this switch, that's hitting the prep button.
Okay, got it.
So
But
prep
those
button,
things happen at the same time.
exposure button. You
Okay.
have to prep then expose. Good. If that doesn't make sense, if you're one of my brand new students, right? Once you get hands on the X-ray machine, it starts to make a lot more sense. But you have to start by picturing it.
Pressing the button connects the C and I, so those two little bridges, right? So pressing the button connects both of those?
I and C would be individual buttons.
Okay.
I would be the prep button that spins the anode disc and charges the filament,
Okay.
and C is the exposure button. So you have two. We always have two buttons, right? So I'm looking at these really small. I is the bottom switch down here at the control console that charges the filament and spins the anode. So that would send. I would send power, which you're not seeing it because they don't show it because it's complicated. I would send power to the stator wrapped around this rotor and begin to spin this rotor, as well as charge this filament, which is like turning a light bulb on. Okay, Lastly, and a little more complicatedly, is the high voltage section of the equipment, okay? The high voltage section is what you see when you have the large, big fat lines running out of some box in your X-ray room to the X-ray tube, and you notice those lines come in one side of the X-ray tube and the other, right? To give you a feel for how big these lines are,
About 2 inches thick.
they're big, right? So this is an X-ray tube, which normally sits above the table. And these big holes here are where the lines go in at, where the high voltage lines go in at, okay? This is your normal stuff, is your normal, household type wire, right? Small 12 or 10 gauge or something like that. These are huge wires that go in here, and you'll see them on our X-ray machine or any other X-ray machine, one side and the other. They represent a positive and negative side of a direct current circuit, okay? So remember, we get alternating current from our wall, okay, which then has to be rectified to become direct current. That's what we finished last class talking about, right? How do you take alternating current and rectify it? I mentioned a little electrical device that can take alternating current and get rid of the negative waveforms. Get rid of the alternating waveform. They're called what? The diode, okay? Diodes are, we'll show a better example of them today. Diodes are an electric device that takes alternating current and just doesn't allow the negative waveforms to go the directions that we don't want it to go, okay? So we can make direct current out of alternating current by rectifying it through something called a rectifier bridge, okay? Let's go back to our diagram. Come on. There it goes. There it goes, okay. So here's your high voltage side. After you've made your kV settings at the auto transformer, you've set your kV, the power wires go to first a step-up transformer. The step-up transformer sends power in one end, down the coils of wire, and out the other end, okay? That doesn't actually activate or do anything, but it does induce current in this wire, okay? Current gets induced through this circuit coming out of the other side, the secondary side of the transformer. This is a step-up transformer. Again, we access, for analogy purposes, let's say 110 volts, and we need to make 110,000 volts, 110 kVp, for example, right? Which is 1,000 times more than what we get from the wall, okay? So we have to have a magnitude more windings on the secondary side, 1,000 times the windings on the secondary side than we do on the primary side. So, 100 windings over here and 100,000 over here, right? Many more, right? So that's going to raise the voltage on this secondary side. Now, this meter shown here, this is what we show meters as on our little circuit diagrams. This meter is actually in line with this coil of wire. It's in the line. It's not spanning one side to the other. It's in the line. Anytime a meter is shown in line in a circuit, not spanning one side to the next, in the line, this is going to be an ammeter. Ammeters measure amperage. Okay, where a voltmeter measures voltage, ammeters measure amperage. On your console, you have two displays. You have the voltage display given by the voltage meter, and you have the amperage display given by the ammeter, okay? When I set my amperage, this machine doesn't plug into power, but if it did and I turned it on, when I set my current level, the amperage meter would move and show me my current level, okay? Show me what the current is. Others will stay at 0. You set whatever you set, and then when you make the exposure, the meter will spike to the actual amperage that you've chosen and show you what it is while the exposure is being made. But either way, there's got to be a meter so we can see what the amperage is and another one to see what the voltage is. That on the secondary side of the step-up transformer is the ammeter. Why wouldn't the ammeter be on the primary side?
Because the ammeter is showing you how much voltage is coming out, right?
The ammeter is showing you how much amperage is traveling across the X-ray tube, and the amperage on this side of the circuit is different than the amperage over here, right? Because this side had lower voltage and higher amperage, right? This side had higher voltage and lower amperage. So we want to measure on the side that we're actually using, right? So, good, that's an ammeter. F is the ammeter. Now G is our rectifier bridge, and in a little while we got a better picture for this. Our rectifier bridge. This rectifier bridge, these little cylinders are diodes, and not shown here very well, but here's the idea. The electricity in the X-ray tube has to come this way, travel across the tube, and out that end, and then down that way, and then back that way, okay? The electricity going through this has to travel only in one direction, okay? Up to here, this line and this line, actually it goes this way, this line, the power going into this rectifier bridge is shaking back and forth, going both directions, okay? But coming out of the rectifier here and into the rectifier, the power's only going in one direction. So power has to enter the rectifier traveling in both directions and then exit the rectifier traveling in only one direction. Enters as alternating current, leaves as direct current. Because of the way these are all lined up, any negative waveforms which would travel backward are redirected to travel in the positive direction. I had a better picture I'll show you in a little bit that shows the arrows and the directions things travel in, which will hopefully make a little more sense. But step-up transformer, raising voltage, ammeter reading the amperage, rectifier bridge converting alternating to direct current, and X-ray tube, which is the source of electrons and is the safe space for the electrons to jump across this gap where we create our X-rays. So let's take what we've got here and now let's apply it to a little more complicated stuff. So what we're going to do now is talk about the transformers and generators a little bit more.